All right, here we are. Well, welcome to Mechanical Engineering 441, otherwise known as Introduction to Robotics. I'm John Steele, and I'm the professor in this course, and I've been teaching this course for quite a while now, since about 2000, and even though it's well worn, we're trying something new this year. We're going to do these video lectures so that you can check them out anytime you want, and that will facilitate us doing more direct interactions and practice in class. So I'm really excited about that, and I hope you are too. I think we'll find that it really facilitates learning. So my goal in this portion, this first video, is to introduce the course and introduce you to some basic concepts that are important in understanding robotics and mechatronics. And I'm going to spend about 10 minutes on this one, and then I'll have another one that will talk a little bit more about the course content and what we're actually going to do. And then I'll have a third one that will talk about DC motors. And these constitute the first lecture, that is the first material for the course. So let's get going. And there's my contact information, and you'll also get handouts that'll let you know how to get a hold of me. Okay, so what is this course about? Well, at one level I could say it's about mechatronics. Robots are really the quintessential example of robots. Robots are the quintessential example of mechatronics. That is, mechatronics is a combination of mechanics, electronics, and software. And that term's actually been around since I was an undergrad. But in those days, and by the way, I went to undergraduate school in the late 60s, graduated with a degree in physics in 1970. But in those days, mechatronics meant electromechanical systems, and primarily it was really just the fusion of electronics and mechanics. And I just replaced a controller in my old dishwasher a couple years ago, and it had a mechanical controller. That is, it ran on a DC motor, but that DC motor was driving a drum, and that drum had the tabs on it that actually actuated the various states and operations in the dishwasher. So anyway, there's some history there. We're going to use a more modern version of mechatronics, which involves the use of software. And that's really come about because of the microprocessor. And I've used that term, but really we use microcontrollers. Microcontrollers are microprocessors that have external connections. So they have memory, and they have digital I/O, and they have analog inputs. So they're more than a microprocessor. So those are the three major components of a mechatronic system, and we're going to look at how they're applied to a robot. So what are the major subsystems in a robot? Well, I'll start with power. Power is often overlooked when people talk about robots, but the fact of the matter is that a robot doesn't do much of anything if it doesn't have power. It might look pretty, but that's about it. And it's really important for us to keep in mind that designing the power system and in understanding power systems and how they work and how they affect our system is a really important part of any robot project, any robot system. Okay, so The next one is perception, and that's a fancy word maybe for sensing, but really for robots, the ability to perceive is critical. And we often think of it in terms of the perception of the robot and its environment, that is, what it can see, if I can use that term, out in the world. And you can think of a robot with a camera and the fact that it can see things around it, or objects maybe. We'll talk about that more later. But perception is also the ability of the robot to sense itself. And we call that proprioception, or proprioceptive sensors. And we have proprioceptive sensors. We measure our body temperature, for example, and we try to maintain a certain body temperature. And you could have a robot that would do the same thing. It could measure the temperature of a DC motor, and it could sound an alarm if that motor got too hot. So, or it could be the temperature of a battery for that matter. So perception can be inward-looking, proprioceptive, or it can be outward-looking, and that's the more interesting and exciting aspect of perception. And it's really one of the critical characteristics of robots, and very important. We're going to talk more about that. The next subsystem is manipulation. And for my money, it's what makes robots robots. So you can have a system that sits there and perceives, a camera sitting on a tripod looking out on the world. Maybe it's watching cars go by, or maybe it's looking at people. But that in and of itself is not a robot. It's only when you combine perception with the ability to manipulate the environment through some action. Maybe typically it's a gripper. You reach out and grab something and move it from one place to the other, or some other way of manipulation. That's what really makes robots interesting in my mind. It's their ability to manipulate the environment. And then finally, and definitely not least, is this idea of decision making. As I mentioned, the old version of mechatronics involved just simple electromechanical systems. Now we have these microcontrollers, and we have all the power of software that we can write and do data collection and data interpretation, and then use all of that data turned into information to make decisions, and those decisions then lead to the next activities or tasks for the robot. And so decision making is again critical to the capability of robots to be tools of interest. Okay, so again, the four major subsystems are power, perception, manipulation, and decision making, and we're going to work with all of those this semester. Okay, so that's about 7 minutes. I will bring up the next slide and then use that as a break-off for our next. So what are we going to study? We're going to study electrical systems, and you see there that we'll talk about sensors, we'll talk about microprocessors and microcontrollers, we'll talk about motor drivers and how they are an integral part of the actual drive system. And in terms of mechanical system things, we're going to talk about motors, we're going to talk about gears, and we're going to talk about mechanism design. And in fact, you're going to use all of those things in this course. In terms of software, I'm going to introduce or reintroduce you to the idea of doing flowcharts as a way of designing your software. And I think it's a very useful tool to help you develop your ideas and work together as a team on your projects. Modern software development has other tools. UML, for example, Universal Modeling Language, is something that software folks use, and I've chosen not to go there because it's a little more involved than we really need to be for what we're doing. And then last but not least, under software, we're going to do algorithm development and look at different ways to create these software programs that give us the capabilities that we need to make the robot do what we want it to do. In addition, we'll talk about robot things. At some point I'll give you a little bit of history of robotics. As an ongoing activity during the semester, we will look at so-called current topics, and I call that Robot of the Week, and I'll talk to you about that a little later. But basically each team's going to come up and give a presentation on a robot that they find interesting, they being you. And then we'll talk about elements of robotic systems and look at how they get integrated into the whole overall package. So that's an introduction to the course, and I'm going to stop here, and then we'll start up again in a moment.